120 light-years from Earth, the James Webb Space Telescope has detected something extraordinary. In the atmosphere of an alien world called K2-18b, scientists found a molecule called dimethyl sulfide, DMS for short. And here's why that matters. On Earth, DMS is only produced by living organisms, specifically by microscopic phytoplankton that fill our oceans and produce the smell we associate with the sea breeze. If this detection is real, it could be the first chemical signature of alien life ever found. But there's a problem. The scientific community is deeply divided. Some researchers call this the strongest evidence yet for extraterrestrial biology. Others say the data is too weak, the detection too uncertain, and the announcement too premature. So what's the truth? Did JWST just change everything we know about life in the universe? Or is this another false alarm in our decades-long search for alien worlds? Let's break down the science, the controversy, and what it all means for humanity's biggest question: are we alone? K2-18b isn't just any exoplanet, it's what astronomers call a sub-Neptune, a world that exists in a size category we don't have in our own solar system. It's about 2.6 times the radius of Earth and 8.6 times our planet's mass. That makes it significantly larger than Earth, but much smaller than Neptune. The planet orbits a red dwarf star called K2-18, located in the constellation Leo, about 120 light-years away. Now, 120 light-years might sound impossibly distant, but in cosmic terms, that's practically our neighborhood. For context, the Milky Way galaxy is 100,000 light-years across. Here's what makes K2-18b special. It orbits within its star's habitable zone, the region where temperatures could allow liquid water to exist. It completes one orbit every 33 days, but don't imagine Earth-like conditions. K2-18b's density is only about half that of Earth, which tells us something crucial about its composition. Scientists believe K2-18b is what's called a Hyson world, a hypothetical type of planet with a massive hydrogen-rich atmosphere sitting atop a global ocean of liquid water. The atmosphere could be hundreds of kilometers thick, creating crushing pressures and temperatures far different from Earth's surface. Think of it as an ocean world wrapped in a thick blanket of hydrogen and helium. The James Webb Space Telescope doesn't take pictures of exoplanets the way you might imagine. Instead, it uses a technique called transmission spectroscopy, and it's absolutely brilliant in its simplicity. Here's how it works. When K2-18b passes in front of its host star, an event called a transit, some of the star's light travels through the planet's atmosphere before reaching us. As that starlight passes through the atmospheric gases, different molecules absorb specific wavelengths of light. Think of it like a chemical fingerprint. Every molecule, water, methane, carbon dioxide, dimethyl sulfide, absorbs light at very specific wavelengths. By splitting the starlight into its component wavelengths and measuring which ones are missing or dimmed, scientists can identify exactly what gases are present in that distant atmosphere. JWST uses an instrument called NIR-SPEC, the near-infrared spectrograph, to capture this data with unprecedented precision. Previous telescopes like Hubble could detect some atmospheric signatures, but JWST's infrared sensitivity and massive 6.5-meter mirror make it 100 times more powerful for this kind of work. In 2023, JWST observed K2-18b during multiple transits, collecting hours of data. The team analyzed the spectrum and found clear signatures of methane and carbon dioxide, both expected in a hydrogen-rich atmosphere. But then they found something else, a faint signal at wavelengths consistent with dimethyl sulfide. And that's where things get interesting. In part 2, we'll dive deep into what DMS actually is, why it matters so much for the search for life, and why the scientific community is so divided about this detection. So keep looking up and asking why, and don't forget to like and subscribe for more interesting science.